The physical world is just atoms and the void. Everything else is opinion. Democritus wrote these words 2,400 years ago, articulating what remains neuroscience's most profound challenge. If reality is merely particles in motion, why do we experience consciousness at all? As philosopher David Chalmers notes, consciousness represents the hard problem, a vast neural labyrinth where each discovery reveals more unexplored corridors. Despite mapping neural correlates and developing sophisticated theories about brain information processing, the explanatory gap persists. Why aren't we just complex robots without inner life? Join our exploration of consciousness through cutting-edge science and the timeless questions about experience itself. Have you ever wondered what happens in your brain when you become aware of something? Your conscious experience feels immediate and unified. But what if I told you your brain processes much of this information before you're even aware of it? Neuroscience has made remarkable strides in mapping the physical basis of consciousness. Using brain imaging technologies like fMRI and EEG, scientists can observe neural activity during conscious experiences, watching as brain regions activate when you see a face or hear a sound. These neural patterns, which scientists call the neural correlates of consciousness, reveal what happens during conscious experience, but not why these patterns create the subjective feeling of awareness. Your visual system works like a film editor, assembling scattered footage into a seamless movie. When light hits your retina, it triggers neural activity through your visual cortex, where color, motion, and shape are processed separately. Yet somehow you perceive a unified visual scene. How does your brain transform these fragmented signals into one coherent experience? Some of the most fascinating evidence comes from experiments manipulating visual awareness. In motion-induced blindness studies, bright yellow dots against moving blue patterns periodically vanish from awareness completely, despite physically remaining on screen. The same signals reach your retina, but your brain stops consciously registering them. This reveals consciousness as something your brain actively constructs, rather than a simple reflection of sensory input. Even more compelling are cases of blindsight. When people with damage to their primary visual cortex claim they cannot see objects in parts of their visual field, they can still accurately point to these invisible objects when asked to guess. Their brains know something their minds don't. What does this tell us about the nature of awareness? It suggests consciousness isn't necessary for certain types of visual processing. The rubber hand illusion further demonstrates how malleable our sense of self can be. When participants watch a rubber hand being stroked, while their hidden hand receives identical touches, they begin experiencing sensations in the rubber hand, incorporating it into their body image. This illusion reveals how our sense of bodily ownership is actively constructed by specific brain mechanisms, rather than being fixed or innate. To pinpoint which neural processes create consciousness, scientists use contrastive analysis, comparing brain activity during conscious versus unconscious processing of identical stimuli. These studies have identified certain brain networks, particularly connections between the thalamus and cerebral cortex, as crucial for conscious awareness. Despite these advances, we face a fundamental limitation. Brain imaging shows correlations between neural activity and conscious experiences, not causation. We can observe which brain areas activate when you see the color red, but why should any pattern of physical activity produce the subjective experience of redness? This represents the central mystery at the heart of consciousness research, the explanatory gap between brain processes and subjective experience that science has yet to bridge. While the neural correlates of consciousness tell us where awareness happens in the brain, they don't explain how or why physical matter creates subjective experience. It's like having detailed blueprints of a television circuitry without understanding how electricity becomes moving images, except the mystery of consciousness runs far deeper. What if every theory of mind we've developed is fundamentally incomplete in ways we can barely comprehend? This explanatory gap between brain activity and conscious experience has prompted scientists to develop competing frameworks to bridge this profound mystery. Three major theories have emerged, each offering a different perspective on the same puzzling territory: higher order theories, global workspace theory, and integrated information theory. Higher order theories propose a hierarchical view of consciousness. Your basic perceptions, what you see, hear, or feel, begin as lower order representations in your brain. These perceptions become conscious only when they're re-represented at higher processing levels, particularly in the prefrontal cortex. Imagine looking at an apple. Your visual system processes its redness unconsciously at first. Only when that information reaches higher brain regions and becomes "I am seeing red" does the experience of redness emerge in your consciousness, like your brain creating a mental reflection of its own activity. Global workspace theory approaches consciousness differently. It suggests awareness arises when information gains access to a distributed workspace across your brain's frontal and parietal regions. As Stanislas Dehaene explains, consciousness arises from the sharing of information among various brain regions. Picture a theater where only information in the spotlight becomes part of conscious experience. When something important requires attention, like a sudden noise, it's broadcast into your global workspace, becoming available to multiple brain systems simultaneously, like an announcement echoing throughout a mental stadium. Integrated information theory takes a more mathematical approach to the explanatory gap. Developed by Giulio Tononi, IIT proposes that consciousness emerges from the integration of information within a system. The unique pattern of relationships among elements defines specific conscious experiences. Tononi argues that consciousness corresponds to the amount of integrated information in a system. The more interconnected and integrated the information, the higher the consciousness level. This perspective suggests consciousness isn't limited to brains. Any sufficiently complex system with the right kind of information integration could possess some form of awareness. These theories predict different neurological homes for consciousness. Higher-order theories point to the prefrontal cortex. Global workspace suggests networks spanning frontal and parietal areas. Integrated information theory implies consciousness emerges from connection patterns throughout your brain rather than residing in specific regions. Yet each theory ultimately confronts the same fundamental question: why should any physical process, no matter how complex, produce subjective experience? Why does integrated information feel like something? Why should broadcasting information create the sensation of awareness? Why would higher-order representations generate qualia, the subjective quality of experiences like the redness of red? The mystery isn't simply about mapping where consciousness happens, it's about understanding why it happens at all. Even our most sophisticated theories describe mechanisms that correlate with consciousness without explaining why these mechanisms generate your subjective experience of being alive and aware in this remarkable universe. As we stand at the frontier of consciousness research, we're facing an exciting horizon of discovery. Our fascination with empirical consciousness studies has evolved from philosophical inquiry into rigorous scientific investigation, reflecting researchers' recognition that once philosophical questions now demand scientific exploration. Mindfulness practices like meditation offer windows into our conscious experience while reshaping the brain structures they help us observe. When you close your eyes and notice your thoughts, you're experiencing the very phenomenon scientists strive to understand. The puzzle of consciousness invites participation rather than spectation. Unlike other scientific enigmas, it exists right now as you process these words. Perhaps the ultimate revelation is recognizing that consciousness research isn't merely about studying an object, it's about the subject becoming aware of its own awareness, where the tool for understanding is also the phenomenon being understood.